I'm going to talk about the technical description, project report theory, chapter 2. At this point, when you get to this section of your report, you should have a nice feeling about your system, meaning you should have some information to help you understand more and more about how your project works. Here, we're no longer going to be talking about the motion sensor detects the temperature in the room, and then the motion sensor will send a signal to the mic controller, and then the mic controller will turn on the light. That's a general description. A technical description is very close to the other section, if not the same. But here you put everything together and you reference your circuit diagram from here. In this section here, you should have a final circuit, meaning that you should have something like a power supply, and that power supply is providing power to your temperature sensor, and the output of the temperature sensor is going to go to a circuit called the analog to digital converter, or in this case, I apologize, an amplifier. And that amplifier has a power, and the output of that amplifier will go to the next step, which is the analog to digital converter. The symbol for analog to digital converter are many. Oops, sorry. But in this case, we're just going to use a square box, and the analog digital converter needs its own power supply. And there are two lines that connects to the microcontroller for communications. And the microcontroller also needs some type of power. And these are the two inputs that I have selected to control or to request information from the analog to digital converter. So we have an analog digital converter, we have a voltage amplifier, we have a temperature sensor, we have a power supply, and we need values. So I'll start with 5 volts. Most of my components here are just 5-volt systems, so it makes it easier for me to explain. This is my microcontroller. These are my inputs. One side of this is a clock, the other side is the data that's coming in. This is the level, the data. What does data mean? It means bits and bits of information are coming in to represent the voltage level from the amplifier. What is the clock? The clock tells me the speed at which the data will be received from the analog to digital converter. The analog digital converter will be receiving a voltage between some number X and Y, and depending upon the input and the output, it has a gain. I must indicate clearly what the gain of the amplifier is and what is also coming from the temperature sensor. What again is the input and the output. So we're talking about a detailed description of what happens between each stage of your input, and also looking at the microcontroller as a power supply because the microcontroller is really some type of power supply, a low current power supply. I think of the microcontroller as a type of power supply, a low current 5-volt power supply, which I control by writing a program. And I can connect things to this power supply. And I can use a program to turn things on and off, such as a lamp. But once again, I have to be very careful. I have to describe in detail what type of circuit am I using to operate this lamp. So if this lamp is, for example, a 12-volt lamp, then I cannot use the same power supply for the microcontroller. I must use a separate power supply, which operates at 12 volts. So now I have two power supplies for my project. Current will come out of here and go through the transistor. Usually there's a resistor to set the voltage for the base. And if I'm using a smaller lamp, then I might have to use a resistor in series. But the important point here is that I am showing you in detail what's happening between the microcontroller and the output, all the steps. So when the output of the microcontroller changes to a 1, that means the output of the microcontroller is around about 3.4 volts. And if it's that level, then you should have a certain amount of current going into the transistor. And that causes the transistor to move into the saturation region. And we all know that when the transistor is in the saturation region, it is fully turned on. That means the voltage from the collector to the emitter will be very, very small, something like 0.3 volts, which means now that this circuit right here will produce around 11.7 volts across this lamp, which is more than enough voltage to operate the lamp successfully. And you also must indicate how much current is being used by that lamp, because you have to be sure that the power supply that you select provides enough current for that lamp. We're talking about a detailed technical description indicating voltage levels, indicating current levels, calculating power levels, also describing signals, whether they're serial or they come together as a group of zeros and ones, and what are the ranges of those zeros and ones, what are the different options. I want to know the exact voltage that's required from the motion sensor that tells the microcontroller to turn on the lamp. So this is where you talk about the system, starting from the sensor to the load. Each one. It should explain the operation of your project in terms of voltage, current, power, signal representation, and circuit parameters. For example, the gain of this amplifier is a parameter. This signal that's coming from here to here is coming in and out, a clock and data. Power, how much power is being used by this power supply? You know, what is the total current? Because I have 4 different circuits here. So I have a current here, I have a current here. All of these circuits need current. So what is the total current? And what size power supply do I need in order to serve this circuit? What are the voltage levels? Right? What type of sensor circuit am I using? What is the minimum and maximum voltage levels? What is the gain? What is the set point? Is there a frequency? Is there some error? Can I depend on this to work within plus or minus 5% of the actual temperature? So this is a technical description. This explains to the engineer how your circuit works, and it also tells the person like me who is evaluating you that you understand your solution to your problem. Even if you get assistance in helping you design the circuit, it is up to you to understand how it works. This is the technical description.